Hi, 8th grade. Welcome back from Easter break. I hope you had a wonderful 10 days away from sustained learning. I hope you're feeling excited to get back at it. Before we left, we started chapter 10. We were working with square roots. We were graphing functions. We were simplifying radical expressions. Today we're going to continue in chapter 10. We're moving on to lesson 3, but before we do that, we'll do a quick warm-up. I'm just going to keep going through, so pause it and give yourself an honest opportunity to solve these two. For the first one, we don't want a square root. We can't have a radical in the bottom, right? So we've got 1 on the top and then 5 times the square root of 7. So the square root is the only thing that can't stay. So we're going to multiply by a fraction equal to 1 with the square root. So the square root of 7 over the square root of 7. The 5 is already whole. So we just leave it, right? So the 5 bounces over. And the square root of 7 times the square root of 7 gives us a regular 7, right? That's the square root of 49. And then on the top, 1 times the square root of 7 gives us the square root of 7. So our final answer is the square root of 7 over 35. For number 2, there's 2 ways to solve this, right? So our original problem is here. The square root of 12 times the square root of 8. So one way, right, the first way to solve is to multiply. 12 times 8. And we get 96. And then from 96, we want to pull out doubles. We want to think of actual squares. Remember, I think it was in 10.2 part 1, we made a list of all the squares. So we want to find some squares that go in to 96, and 16 does, among others, but 16 was the one I thought of. And the square root of 16 is 4, and there's no squares in 6. So our answer is 4 square root 6. We could have left it, the square root of 12 and the square root of 8, and just simplified those individually. So the square root of 12 is 4 times 3, and the square root of 4 is 2. So 2 comes on the outside times 3, the square root of 3 on the inside. And then 8 is 4 times 2, and the square root of 4 is 2. So 2 comes out, and it leaves a 2 on the inside. And when we multiply the outside by the outside, 2 times 2 is 4. And then when we multiply the root times the root, 3 times 2, we get the square root of 6. So in either case, we end up with the same answer. Okay? So hopefully that refreshes your mind and gets you ready for 10.3, which is operations with radical expressions. So today we're going to be taking a look at math operations, mostly adding and subtracting, and we're going to have the square roots involved in every term, okay? We want to keep in mind, if we just jump right into an example, these square roots are they're kind of like a label. In order to combine the outside numbers, these have to be the same. Okay? These have to be the same. So for example, if I had 2 square root 3 plus 4 square root 7, this is simplified. This is already done. There's nothing to do here, okay? Because 3 and 7, they can't be broken down more. They have no doubles, no squares, and they're not the same. So we cannot combine the 2 and the 4, okay? So in this first example, we have square root 7, square root 7. They're the same, right? So it's like a same label, which means they can be combined. So we have a negative 10 and a positive 12. Negative 10 and a positive 12 is 2. And then the label stays the same. So the answer is 2 root 7. Okay? Let's do another one. Let's say we have negative 10 and the square root of 11 minus 11 times the square root of 11. So again, the square roots, they're the same. which means we can combine. So we've got a negative 10 and a negative 11, which is negative 21. Okay? Easy enough. All right. Of course, we're not going to stop there. We're going to build on it a little bit. Okay, sometimes the roots aren't going to be the same initially, but they're still combinable. And here's what I mean. Let's say we have 3 and the square root of 8 plus 3 and the square root of 2. In order to find out if we can combine them, we can't like this, right? We have 2 and an 8 on the inside, so we can't like this. But 8 has a square in it, right? So we can write this, the square root of 4 and the square root of 2, right? 4 times 2 is 8. And the square root of 4 is 2. So 3 times 2, square root 2, okay? Which is 6 root 2. This is all the work. We don't have to show all of it, right? I'm just trying to remind you we just got back from a 10-day break, okay? And then we have plus 3 root 2. Nothing to do with it, okay? Just bringing it down. So the 2's now, root 2's, are the same, which means we combine the 3 and the 6, right? 6 plus 3 is 9 square root 2. So if initially they aren't the same, make sure that you check to be sure that they can't be simplified to be the same. How about you guys try one? Negative 3 times the square root of 20 minus the square root of 5. So I'm working on this on my own, and I hope that you're trying it on your own. Okay. If you need a minute, pause it. Otherwise, you should have gotten negative 7 times the square root of 5, right? Because this negative square root 5, there's one of them there. So when we combine, we have negative 6 and negative 1 more, which is a total of negative 7. All right. Continue increasing the difficulty here. Let's take a look at the square root of 2/3 minus the square root of 6. So keeping in mind from before we left on break, a fraction is just both of them square rooted, right? So the square root of 2 over the square root of 3. We can't have a radical in the denominator, so we're going to multiply it by 3 over 3, the square root of 3 over the square root of 3, which means on the bottom we have the square root of 9, which is 3, right? And then on the top we have the square root of 6. Okay, so we're going to leave that as the square root of 6 over 3, and then we have minus the square root of 6, right? This is the same one. And then this turned in to this. Okay? And much like in this last one that we tried where there was nothing, it was a 1, right? That imaginary 1. This can be rewritten as well, right? So this can be 1/3 times the square root of 6 minus, and then this one can be written 1 times the square root of 6. Okay? So I use parentheses here because in a fraction, I just am used to doing that. But we don't even have to show that, right? It can be 1/3 square root 6 minus 1 square root 6. Okay, they mean the same thing. And now they're in that position of a label and they're the same. So we can combine them. So here we have a 1/3, and then we have a -1. So the difference between a positive 1/3 and a -1 is -2/3. And then we have our label that needs to stay. Okay? This is one of the trickier ones that you'll see, for sure. Let's try another one. Okay. This time we're going to do a 3-term example. Let's say we have 8 times 5/4, the square root of 5/4, and then plus 3 times the square root of 20 minus 10 square root of 1/5. Okay? So none of them are the same right off the bat. We're going to have to change all 3 of them. So if I start with 8 times the square root of 5/4, I need to, so 8, is like 8/1, right? And then we have the fraction. So we've got 5/4 square root. And we're going to multiply this by the square root of 4 over the square root of 4 to get that radical out of the denominator, which equals on the top 8 times the square root of 5 times the square root of 4. And on the bottom, we have the square root of 16. Okay, so then on the top, we have 8. So the square root of 5 is going to stay, right? It can't be simplified down. And the square root of 4 is 2, right? This turns into a 2. And then 8 times 2 is 16. Okay? So I have 16 root 5 over, and the square root of 16 is 4. Okay? And then this can be simplified even farther. 4 goes into 16 4 times. So my answer for this first term, simplified, is 4 square root 5. Okay? So now if I take my second term, so 3 square root 20, and I simplify that one, I'm going to continue going this way, okay? Turns into 3 times the square root of, and I want to use squares, right? So 4 times the square root of 5, and 3 stays the same, and then the square root of 4 is 2 times the square root of 5, which turns into, and it was a plus, so I'm just going to keep that, plus 6 root 5. So the fact that now these two have the same square root, I think I'm on the right track, right? That's a good checking point. And then I need to take my last one. So if I just 1, it's my first term, 2, second term, and then my third. Just keep it organized. I have 10, and then the square root of 1/5, which is 10, right, over 1, times the square root of 1 over the square root of 5, multiplied by the square root of 5 over the square root of 5 to cancel that out. On the bottom, I have the square root of 25, which is 5. And then on the top, I have 10, and then I have 1 times 5, which is the square root of 5. And then over here, 5 can go into 10, so I'm left with a negative 2 times the square root of 5. So now my terms, 4 square root 5 plus 6 square root 5 minus 2 square root 5. These are all the same, so I can combine all of the beginning. Okay, so 4 plus 6 is 10, minus 2 is 8. So I end up with 8 times the square root of 5. Okay, you ready to try one? Here's yours. 3 terms. Three times the square root of 18 plus 3 times the square root of 12 plus 2 times the square root of 27. I'm going to give you a second to solve for that. Pause it if you haven't. Your answer should be 9 square root 2 plus 12 square root 3. So it looked like only 2 of them can be combined. Okay, so the one that can't be just stays the same, and then the 2 that have the same roots, you combine those. Okay, one more. This one's for you as well. I'm going to solve this one quiet. -3 square root 2 plus 3 times the square root of 20 minus 3 square root 8. Okay. So like the last one, there's 2 different kinds of square roots. We can only combine the square root of 2, and our answer is -9 square root 2 plus 6 square root 5. Just a reminder that there's multiple ways to solve a problem. Let's say we have the square root of 32 times the square root of 2. We can break down 32 into some squares, right? So we've got 32 is 4 times 8, which the square root of 4 is 2, right? And then 8 is the square root of 4 times the square root of 2. And the square root of 4 is 2 again. So we end up with 2 times 2 times the square root of 2. Right? And then if we bring this last guy down, times the square root of 2, we end up with the square root of 4, and we end up with 2 times 2 times 2, which is a final answer of 8. Or, this was kind of like our warm-up, we could take the square root of 32 times the square root of 2 and multiply them initially. So the square root of 64, which is a perfect square. And so none of this breakdown is necessary because the square root of 64 is 8. However, if you don't know your squares and you have to do it this way, there's no right way to solve, right? There is a right answer. Okay, last ones to try. -4 square root 15 times the square root of 3. Okay, we're all going to solve this one together. So 15 is the square root of 5 times the square root of 3. And then we have times another square root of 3. So this is the square root of 5 times the square root of 9. The square root of 9 is 3. So we have 4 times 3 times the square root of 5, which is -12 square root 5. Okay. All right. For homework. For homework tonight or today, whatever time it is that you're working on this. We are going to be on page think our homework's going to be different from the other group. Sorry about that. Oh, here we go. Page 638. And we're going to do problems 15 through 31 odd. And then also, let's do 44 through 49. If you have any questions, let me know.